definition of sound. Sound refers to the physical phenomenon of waves traveling through a medium, such as air, and producing an auditory sensation in the human ear. These waves are characterized by their frequency, which determines the pitch of the sound, and their amplitude, which determines the loudness. Detailed definition of sound. Sound is a physical phenomenon that can be described as a series of pressure waves that propagate through a medium, such as air or water. When an object vibrates, it creates pressure waves that travel through the surrounding medium, causing the particles in the medium to vibrate as well. These vibrations are then transmitted through the air or other medium until they reach our ears, where they are detected and interpreted as sound. The intensity or loudness of sound is measured in decibels, decibel, with a range of 0 decibels the threshold of hearing, to 120 decibels the threshold of pain. The pitch or frequency of sound is measured in hertz, with a range of 20 Hz, the lowest frequency we can hear, to 20,000 Hz, the highest frequency we can hear. Different sounds can be produced by different sources, such as musical instruments, human voices, or machines. The quality or timbre of a sound is determined by the complex pattern of overtones and harmonics that accompany the fundamental frequency. Sound can also be affected by various environmental factors, such as reflections, absorption, and diffraction, which can alter the way in which sound waves propagate through a space. The study of sound waves and their behavior is known as acoustics. This field has many practical applications, including noise control, architectural acoustics, and ultrasonic. Uses of sound. Sound has many uses in our everyday lives, including communication, entertainment, and safety. Some examples of the uses of sound are: communication. Sound is essential for verbal communication, whether it's in person, over the phone, or through a video call. It allows us to convey information and ideas to others, and to receive feedback and responses. Entertainment. Sound is a crucial part of music, movies, and other forms of entertainment. It adds depth and emotion to the experience and can enhance our enjoyment of it. Safety. Sound can also be used to alert us to danger. For example, sirens and alarms are used to warn us of emergencies, and horns and whistles are used to signal oncoming vehicles or dangerous situations. Navigation. Sound can be used to help us navigate our environment. For example, echolocation is used by some animals to navigate in the dark, and sonar is used by boats and submarines to detect objects underwater. Therapy. Sound can also be used therapeutically to promote relaxation, relieve stress, and improve mental health. This is known as sound therapy or music therapy. Scientific uses of sound. Non-destructive testing. Sound waves can be used to detect flaws or defects in materials without causing damage. This is known as non-destructive testing and is used in industries such as aerospace, manufacturing, and construction. Uses of sonar. Sonar is a technique that uses sound waves to detect objects underwater. It is used in marine navigation, fishing, and military applications. Uses of ultrasound imaging. Ultrasound imaging uses high-frequency sound waves to create images of internal organs and tissues. It is used in medical diagnostics, as well as in industrial testing and quality control. Material testing. Sound waves can be used to measure the properties of materials, such as their elasticity, density, and strength. This is used in industries such as aerospace, automotive, and construction. Speech recognition. Sound waves are used in speech recognition technology, which allows computers to understand and interpret human speech. This is used in applications such as virtual assistants, speech-to-text software, and voice-activated devices. Audio engineering. Sound waves are used in audio engineering to create and manipulate sound recordings. This includes recording, mixing, and mastering music, as well as designing and programming audio for films, TV shows, and video games. Sound is also used in various industrial processes, such as in manufacturing, quality control, and testing. Properties of sound. Sound is a physical phenomenon that occurs when waves of pressure and displacement travel through a medium, such as air or water, and are detected by the human ear. These waves are characterized by their properties, including frequency, wavelength, amplitude, and velocity. Frequency. The frequency of a sound wave is the number of complete cycles it completes per second, and is measured in hertz. The human ear can detect frequencies in the range of 20 Hz to 20,000 Hz, with lower frequencies perceived as bass and higher frequencies as treble. The frequency of a sound wave determines its pitch, with higher frequencies producing higher pitched sounds. Wavelength. The wavelength of a sound wave is the distance between two adjacent points that are in phase, and is related to the frequency and speed of the wave. Wavelength determines the size of the resonating object that can produce or detect a sound wave, with longer wavelengths requiring larger objects. Amplitude. The amplitude of a sound wave is the measure of its maximum displacement from the equilibrium position, and is measured in decibels, decibel. The amplitude of a sound wave determines its loudness, with larger amplitudes producing louder sounds. The threshold of human hearing is around 0 decibels, and the threshold of pain is around 120 decibels. Velocity. Velocity refers to the speed at which a sound wave travels through a medium. The speed of sound varies depending on the medium through which it travels, and is affected by factors such as temperature, pressure, and humidity. In air at room temperature, sound travels at a speed of approximately 343 meters per second. The speed of sound is important for determining the time delay between the production and reception of a sound wave, and for predicting the behavior of sound waves in different environments. Phase. The phase of a sound wave refers to the relative position of its waveform at a given point in time. When two sound waves have the same frequency and are in phase, they will interfere constructively and produce a sound wave with a larger amplitude. When two sound waves have the same frequency and are out of phase, they will interfere destructively and produce a sound wave with a smaller amplitude. Timbre. The timbre of a sound wave is its unique quality or character, which distinguishes it from other sounds with the same pitch and loudness. Timbre is determined by the shape and complexity of the waveform, and is affected by factors such as harmonics, overtones, and envelope. Factors affecting sound. Distance. As sound waves travel through a medium, their energy is dispersed and their amplitude decreases with distance. This means that sound becomes quieter the further away you are from the source. This is because the energy of the sound wave is spread out over a larger area as it travels, resulting in a decrease in intensity. The inverse square law states that the intensity of sound decreases with the square of the distance from the source. Medium. The properties of the medium through which sound waves travel can affect their speed, direction, and intensity. For example, sound travels faster in solids than in liquids or gases. This is because the molecules in solids are packed more tightly together, allowing sound waves to travel faster through them. Sound waves also refract when they pass from one medium to another, which can cause them to change direction or be focused. In addition, different materials can absorb or reflect sound waves differently, depending on their density, elasticity, and other physical properties. Temperature. The speed of sound is affected by temperature, with higher temperatures resulting in faster sound propagation. This can cause sound to be refracted or absorbed differently in different parts of the atmosphere or in different materials. For example, the speed of sound increases with altitude in the atmosphere, due to the decrease in air pressure and temperature. This causes sound to refract upwards, resulting in phenomena such as sound shadows and long-distance sound propagation. Frequency. The properties of sound waves, such as their frequency and wavelength, can affect how they are absorbed, reflected, or transmitted through different materials. This is why certain frequencies of sound are more effective for different applications, such as ultrasonic cleaning or medical imaging. For example, high-frequency sound waves are more effective at penetrating solid materials than low-frequency sound waves, due to their shorter wavelength and higher energy. Obstacles. Obstacles in the path of a sound wave can cause it to be reflected, diffracted, or absorbed. This can affect the direction and intensity of the sound, as well as its timbre and phase. For example, sound waves can be reflected off walls or other objects, resulting in echoes or reverberation. Sound waves can also diffract around obstacles, causing them to bend and spread out, which can result in diffraction patterns or interference effects. Interference. When two or more sound waves interact, they can interfere constructively or destructively, resulting in changes in their amplitude or phase. This can cause sound to be amplified or cancelled out, depending on the phase relationship between the waves. For example, when two sound waves with the same frequency and amplitude are in phase, they will interfere constructively, resulting in a sound wave with twice the amplitude. When the two waves are out of phase, they will interfere destructively, resulting in cancellation of the sound wave. This is the principle behind noise-cancelling headphones and other applications of sound interference.